Page 3 of our review now. Are these lines going to be parallel, perpendicular, coinciding, or none of those? So if they're going to be parallel, they will have the same slope. Perpendicular, opposite reciprocal slopes. Coinciding will be same slope and y-intercept, and none will just be none of those. So we can get our slope from standard form by doing the opposite of A over B. Opposite of A is -4, B is 1, so we have a slope of -4. The slope here, opposite of 3 is -3, B is 12, so that gives me -1/4. All right, so these are not the same, so they're not parallel or coinciding. They are reciprocals, but they're not opposite signs, so it's not perpendicular. So these lines are none of those, which means it's a pair of intersecting lines that do not form a right angle. M here is opposite of 12 over 6, which is -2. And here, M is opposite of 1 over -2, which is 1/2. These are opposite signs and reciprocals, so these lines are perpendicular. Okay, write the standard form of an equation parallel to the given equation that passes through the point with these coordinates. So the slope of this line is the opposite of B, or opposite of A, -5 over B, 2. The slope of a parallel line would be the same, -5 over 2. So we've got y minus y1 equals m times x minus x1. Okay, so that's y plus 15 equals, and I can distribute -5/2 x, and then positive 5 times 8 is 40, divided by 2 is 20. I'm going to put the constants on the right, the variables on the left. So I get 5/2 x plus y equals, and then 20 minus 15 is 5. Okay, now A, B, and C all have to be positive, or all have to be integers, and A has to be positive. A is already positive, but it's not an integer, so I'm going to multiply by 2 all the way through this equation. So I'll get 5x plus 2y equals 10. Okay, very similar skill here, except this time it is perpendicular. So we start with the slope, which is the opposite of A over B. So that's 2/5. The slope of a perpendicular line is the opposite reciprocal, -5 over 2. So we have y minus y1 equals m times x minus x1. Distribute y minus 1 equals -5/2 x plus 5 times 10 is 50, divided by 2 is 25. Okay, switch sides with variables and constants, and we get 5/2 x plus y equals 26. I have a fraction here, so I'm going to multiply by that denominator. 5x plus 2y equals 52. And last for this page, we're going to graph a piecewise function. Okay, so I've got f of x equals -5. but only for x is less than -3. So here is where x is -3. And I can only graph on the less than side, the left side. Y equals -5. And I'm going to put a circle there. And there's my line, my ray really, for y equals -5, but only left of -3. And it's less than, but not equal to, so I do not want to fill that in. The next one has a domain of -2 to 4, so it's going to be graphed between -2 and 4. Okay, and the line is y equals -3/2 x, and that's like a +0, so I've got a y-intercept of 0. And I'm inside the domain, so I can actually plot that point. -3/2, down 3, right 2, down 3, right 2, and that puts me right on the edge of the domain. I'm going to put a circle there. I can also go up 3 and left 2, and that puts me on the other edge. I'll put a circle there. I can connect these. Okay, now greater than -2. I want to leave that open. Less than or equal to 4. Or equal to means I want to close this one. And our last line is greater than 4. So I've got my domain already set. It's to the right side, the greater than side of 4. The y-intercept is -4, so on the y-axis I go down 4, but I'm not in the domain, so I don't actually put a point there. Then I follow the slope of 1/2, up 1 over 2, still not in the domain, up 1 over 2, now I'm at the domain, I'll put a circle there, and then continue up 1 over 2, and that ray will finish the graph, and it is greater than but not equal to, so I want to leave that open.